Welcome back to Jackson Square. Today we are still looking at Chapter 5 and we're looking at ways to make equivalent expressions or equations. So we're going to reference TEK 6.7d as well as 6.7a, which says I can generate equivalent expressions using the properties of operation, or I can generate equivalent numeric expressions using order of operation, using whole numbers and exponents, prime factorization. So we're going to be looking at definitely generating equivalent expressions. So I'm going to focus mostly on our operations, okay? So when you are looking at these examples, I want you to be thinking about distributive property. I want you to be thinking about associative property. Grouping is going to be important, as well as distributing things, okay? So let's jump right in. This first page says Gabriel's expression. Gabriel and Kayla each received the same set of tiles. They arranged them differently, and they also wrote different expressions to represent their tiles. What expression do you think Gabriel might have written? So take a second, look at their tiles, and then type in the box what expression you think was written. Okay? Hopefully you looked at Gabriel and you saw there were 3 X's and there were 6 1s. And I hope that you typed in the box 3X plus 6. Okay? Next, it says Kayla's expression. You said Gabriel might have written 3X plus 6. What expression do you think Kayla might have written? Look at Kayla's picture. What do you think she wrote? She broke hers up differently from Gabriel. So what I hope you notice is that Kayla has hers broken into 3 groups. She has 3 groups, and in each group she has X plus 2. So you have to think about that distributive property. She has 3 groups of X plus 2. So what should you have typed? Hopefully you typed 3 times the quantity of X plus 2, or 3 times the sum of X and 2, okay? Here's what Gabriel and Kayla actually wrote. These expressions are equivalent. What do you think that means? What does equivalent mean? Elaborate and type it in the box. So we know equivalent means the same amount, but regardless of what the value of X is, if X is 2, X is 3, X is 4, X is 25, if you look at Gabriel's tiles and Kayla's tiles, they have the same tiles and the same types of tiles. They both have 3 green X's, and they both have 6 orange 1s. And that means that they have the same amount. They're just arranged differently. He grouped his one way and she grouped hers another way. But they represent the same thing. At the end of the day, they're the same amount. So equivalent means they represent the same amount. Here, which of the following expressions can be used to represent the tiles shown? Look at the tiles. I want you to think about Gabriel and Kayla. How was one arranged and how was the other arranged? Select all that apply. What answers could you select for this picture? Okay, so hopefully you were thinking like Gabriel and thinking like Kayla, and you started with the obvious that there are 8 A's and there are 4 B's. But then if you thought about Kayla's way, you could group them. This is 1, 2, 3, 4 groups. And in each group, I could have 2 A's and 1 B. So do I see that option? 2 groups with 4 groups, with 2 A's and 1 B. Yes. So I have 2, I keep saying 2, y'all. I have 4 groups, and in each group there are 2 A's and 1 B. So these are the answers that you should have selected. You said these expressions represent the tiles, 8A plus 4B and 4 groups of 2A plus B. Marco arranged the tiles in this way and then wrote an expression based on his arrangement. What expression do you think Marco might have written? So take a second, look at Marco's picture, and show what Marco could have written. So we see that Marco took his and broke them into 2 groups. And in each group, he has 4 A's and 2 B's. In this one group, he has 4 A's and 2 B's. So Marco could have written 2 groups of 4A plus 2B. 2 groups of 4A and 2B, because he has 1 group, 2 groups, and it still gives us what? The same 8A and 4B that was in the picture before, right? So now that you have taken some time to practice with me, let's go in and you're going to practice by yourself. You're going to match up. There are 6 groups with 3 cards each plus 2 leftover cards. So you're going to look at the picture and you're going to match it up with the expression, and you should have 3 cards matched up together, and then you should have just 2 left over in the end. So take that time to practice. Then you have one more slide. You're going to use your knowledge of distributive property, and you're going to write equivalent expressions for these 2 leftovers. Good luck.